For part A, we need to use the basic properties of limits. Define the limit as x approaches 3 of x squared plus 2x plus 5. So here's what I'm going to do. I'm going to show you first the way that most people go about doing this, and it's pretty much how everyone works these problems. But the problem with just doing it this way is that you don't understand what's actually going on behind the scenes. And when you approach a problem that doesn't behave quite like this nice function right here, you're going to have an issue finding the limit. So here's the approach. People will typically recognize that this is a continuous function, and they'll use this idea in reverse, that the limit as x approaches 3 of a continuous function. We can just plug this guy in for x. So what they'll typically do is they'll say, okay, this is equal to 3 squared plus 2 times 3 plus 5, which is 9 plus 6 plus 5, or 20. That's what people like to do. Now, that's not finding the limit. Okay, although it does give us the limiting value, okay, it does give us the correct answer, it's the wrong idea behind it. What we've done is we've taken a function at 3 and we've noticed that its exact height value at 3 is 20. That's what we've done. Now it works in this case because this function is continuous around those. But what if I had a function that looked something like this, where this guy was at a height of 5? Now with that open circle there, the limit is 5, although the function evaluated at 3 is 20. So this is a mistake, although that's usually how the limit is found in practice, just because we already know that that function is continuous. You're really putting the cart before the horse. Let me go ahead and show you how you're supposed to do this. Okay, so that's mathematically rigorous. We have a bunch of properties on page 60, and I'm going to use those properties to evaluate this limit. We're going to come up with the same answer, 20. The answer is not what's important. It's this process that I show you. So I will expect on exams for you to show me this process. So here's how it works. The first of these rules here that I'm going to use is we're going to assume that each of these separate limits exist. The limit as x approaches 3 of x squared exists, the limit as x approaches 3 of 2x exists, and the limit as x approaches 3 of 5 exists. They do all exist. So this is equal to, I can split this guy up like this. The reason I can do that is because each of these individual limits actually exists. So we can say the limit of the sums is equal to the sum of each of the limits. Okay, the limit of the sums is equal to the sum of the limits. You'll hear people say that a lot. So what I've just used here is the first rule on page 60, which is the sum rule. As you're going through doing these limits, you should write down which rule are you using at each step. This thing right here, I'm going to break this down further. I'm going to say that this guy right here is equal to the limit as x approaches 3 of x times the limit as x approaches 3 of x plus the limit as x approaches 3 of 2 plus the limit as x approaches 3 of x plus the limit as x approaches 3 of 5. The rule that I've used here now is the product rule, okay, on that same page. So this guy right here is the product rule. And why it's the product rule is I've said that x squared is x times x. Okay, so there's two separate functions there, and I've split them. Okay, let's go a little bit further. There is an identity function rule that says the limit as x approaches 3 of x, this guy right here, is equal to 3. Okay, so the rule that I'm going to use right here, let me erase this, actually, we'll just get some more room here. This rule that I used to go in this step right here, that is the identity function rule. Okay, so that's how I go from here to here. Same thing here. So the limit as x approaches 3 of just x again is equal to 3. So the limit as x approaches 3 of x times the limit as x approaches 3 of x is 3 times 3, which is 9. The limit as x approaches 3 of 2, that's under the constant rule function. So this is just equal to 2. So look at that rule, the constant rule function in your book on page 60, and you'll see that the limit as x approaches 3 of 2 is just 2. The reason for that is the function y equals 2 is a flat line. And so at 3, its height, its limiting value, is whatever the height of the function is, which is 2. So this guy's equal to 2. We already know from before that the limit as x approaches 3 of x is 3. So this guy's a 3. Okay. And we know that the limit as x approaches 3 of 5 from that constant rule is 5. So 9 times 9, excuse me, 3 times 3 is 9, plus 2, plus 3. Oops, this is supposed to be multiplication here, I'm sorry. Right, the reason it's multiplication is because it was 2 times x and I split those up. So that's multiplication. It's multiplication here. So that's 9 plus 6 plus 5, and there it is again, that's 20. This, what I need to see on your or on your exams, is I need to see this breakdown right here. Okay? Now you don't have to write which rule you're using because it's going to be obvious to me which rule you're using, but you do have to break them down to the rules on page 60. Okay? If you want to go back later and just direct substitute to make sure you got the right answer, that's fine. But what's important here is not that you get to the answer, but they use the correct process. So no points for just giving me the number 20 on the exam. If on the exam you just give me the number 20, I won't give you points for it. I need to see these steps right here. For part B, we need to go ahead and show that the limit as x approaches 3 of 2x squared minus 7x plus 3 over x minus 3 is 5. Again, we have to use the basic properties of limits. Now watch what happens here if you try to pull the trick that we just did this last time. So on A, so let me write this down. For A, we said that the limit as x approaches 3 of x squared plus 2x plus 5 was equal to 3 squared plus 2 times 3 plus 5, 9 plus 6 plus 5. And I told you that this is not the way to go about the solution. We actually have to show the limit laws, and so you just saw that. Watch what happens here when you try to do a direct substitution. So for B, we want to find the limit as x approaches 3 again of 2x squared minus 7x plus 3 over x minus 3. We want to show this equal to 5. Well, if you do a direct substitution, you get the following. 2 times 3 squared minus 7 times 3 plus 3 over 3 minus 3. Now hopefully you notice that there's an issue here. The top, doesn't really matter what it is. 3 times 3 is 9 times 2 is 18. 18 plus 3 is 21. 21 minus 21 is 0. On the bottom I get 3 minus 3 and I get 0. Well, there's an issue here because we are dividing by 0. So what's going on? Well, this graph right here, if you look at it, at 3, there's a hole in the function. There's a hole in the graph, and that's why we're getting this division by 0. But we don't care about the function at the actual value. We just care what's happening as we approach from both sides. What height value are we coming in towards? Well, that value should be 5. So let's go ahead and see how you get that value out. So we can't do a direct substitution. So if you tell me on the exam that the limit for this doesn't exist, you can get 0 points. So here's how we go ahead and solve that. The first thing to do is we're going to use, this is from page 60, again, we're going to use the replacement rule. And here's what it says. The replacement rule says that 2x squared minus 7x plus 3 over x minus 3 is equal to the following functions. Before I actually show what it's equal to, I'm going to do a little bit of simplification here. I'm going to factor out a 2. I shouldn't say I'm going to factor out a 2. There's a couple ways of factoring this guy by hand. Let me show you one of the tricks so that I don't just do it all in my head here for you. One of the tricks for factoring this is to take the 2 and the 3 and multiply them together. Okay, so if you're bad at factoring, maybe this will help you. So now I'm going to take that 6 and I'm going to break it down to all of its factors. So 1 and 6 and 2 and 3. Now I'm going to look at each of these pairs and say, do any of them add or subtract to give me this middle number, 7, and 1 and 6 do. So what I'm going to do is I'm going to take that negative 7x, I'm going to break it down to minus 6x minus x. So I've just taken negative 7x and rewritten it as 6x and x, negative for both of them. Now I'm going to take the first two, I'm going to factor here by grouping. So the first two I'm going to factor out a 2x, and I'm left with x minus 3. And the last two I'm going to factor out a negative 1, so I'm left with x minus 3. And then I'm going to factor out an x minus 3. Of course, there is a 1 here. And so what that tells me is that 2x squared minus 7x plus 3 is equal to x minus 3 times 2x minus 1. So let me erase this. And so what I've got is 2x minus 1 times x minus 3 over x minus 3. This is exactly equal to this. Now, the next step is to take these two guys and cancel them out. And so what we're going to say is that this guy is equal to 2x minus 1 for all values where x is not equal to 3. So look, if x is equal to 3, let's show you these two are not equal to each other when x is 3. Watch. If I take 3 and I plug it into this left side, I get 0 over 0. If I take 3 and I plug into the right side, I get 6 minus 1, which is 5. 0 over 0 is clearly not 5. So these two are not equal, so it's really important, not equal when x is 3. When x is any other number, doesn't matter what it is, then they are equal. You pick another number, okay? Pick x equals, I don't know, 7. Take 7, plug it in over here, see what you get out, and then plug 7 over here and see what you get out. I promise you both sides will be the same. Okay? So what's the big idea? Well, what we've done is we've said that these two guys are equal to one another for every value except for 3. Well, when we're looking at a limit at 3, we don't care about 3. We just care about numbers around it. So for numbers around it, these two guys are equal. So I can replace the guy on the left with the guy on the right. And so this becomes the limit as x approaches 3 of 2x minus 1. So I've done a huge simplification here. I've went from here to here. The reason I can do that, so let's just be very careful. This guy up here is not actually equal to this guy down here. They're two different functions. This guy's got a hole in it at 3. This guy doesn't have a hole in it at 3. But I can use this guy as a replacement for this guy when I'm looking at the limit as x goes to 3, because these two guys are equal to each other for every value that's not 3, and the limit does not concern itself at 3. It only concerns itself at other different values. So this is a legitimate move from here to here. Don't become mechanical. Don't just always say, well, I can just quick reduce. Make sure you understand why you can reduce, what's going on with the pictures. The picture up top has a hole in it. The picture on the bottom doesn't. But we're looking for the limits at that point. So I'm only looking at the values as I get towards that hole, which are the same as the values towards the filled in point. So hole, filled in point, but they got the same limits. Okay, that's the idea. Now we go back to what we were doing before. So this is a limit as x approaches 3 of 2x minus the limit as x approaches 3 of 1. You do have to go through every logical step. You can't just skip steps and say, well, I did it in my head. An argument in mathematics or a solution is correct if you show all steps. You're trying to prove to someone that your solution is correct, not trying to arrive at the solution. We all can find the limit, and any computer program can find the limiting value. Your job is to prove that that limiting value is correct. So this right here is the limit as x approaches 3 of 2 times the limit as x approaches 3 of x, still minus the limit as x approaches 3 of 1. Now, this rule right here was the product rule. This was the sum rule. So sum, product. This is the constant rule. This is the identity rule. This is the constant rule. So we got to 5. This is the part that counts. If you don't have this and you just give me this, no points. Oops, there's not an apostrophe there, but you get the idea. No points. Okay, so don't come back and complain later if you don't put these steps down. I'm not going to give you any points, and I'm going to refer you to this video, and then I'm going to question whether you're watching the videos or not. Okay. So for C, let's go ahead and work C now. C is find the limit as the variable u approaches 2 of 8u squared plus 2 over u minus 1. Well, here we should see if we can factor anything out of the top and the bottom. If we can factor it, we have to be careful to make sure that what we factor out doesn't cause holes in other portions of the graph. It can only cause a hole at the limiting value. Now, that's not going to be an issue here because when I plug in 2 into the numerator and the denominator, I don't get 0 over 0, what we call an indeterminate form. So we can write this like follows. Limit, you get so used to writing one variable. So the limit as u approaches 2 of 8u squared plus 2 over the limit as u approaches 2 of u minus 1. Now the reason I knew in this problem to use, this is called the reciprocal rule or the quotient rule. The reason I used that rule here is because if I direct substitute 2 in, it doesn't give me the indeterminate form. So you only need to factor, need to factor when you get 0 over 0, the indeterminate form. If you get something over something else that's not 0 over 0, then you proceed directly using these rules, and you don't have to worry about that replacement rule. So this right here, I'm going to rewrite it down here so I've got more room. This is the limit as u approaches 2. So again, this was quotient or reciprocal rule. That's step number 1. Step number 2 is going to be to start splitting these up using the product rule. And the sum rule. So I'm going to do a sum rule here to split these guys up, and the product rule. Okay, so this guy split from this guy is the product, or the sum rule. This guy right here split up as the product rule. Over again a sum rule. So you might say, well, there's a negative in here, but that's all right. You can do plus or minus. Okay. Okay, so I want to see from here to here. Now the limit as u approaches 2 of 8 is 8. Constant rule. Identity rule. Identity rule. Constant. Identity. Constant. So 8 times 2 times 2. 8 times 2 is 16, times 2 is 32, plus 2 is 34, over 2 minus 1, which is 1. So you get this limiting value of 34. Now what I would recommend you do is take this guy right here, graph it out using a calculator, and make sure that the values close to u equals 2 are 34.